Hi everyone, we are still in the introductory topics towards Calculus 1. The last videos pertaining to introductory topics will focus on trigonometric functions, and in this first section we're going to introduce the main trigonometric functions themselves. So many of you have been introduced to trigonometric functions through the use of right triangles, and perhaps you've heard of the SOH-CAH TOA approach. If you haven't, let's think of a right triangle with an angle theta not being the right angle, obviously. The hypotenuse is always the longer side of the right triangle, and then we have the opposite side to the angle theta and the adjacent side to the angle theta. So the hypotenuse, the opposite, and the adjacent are obviously of a certain length. The sine of theta is the ratio of the length of the opposite over the hypotenuse. So that's where the SO comes from. Notice how sine, opposite, hypotenuse. That's the SO part. And then we've got the CAH part. Cos of theta is the ratio of the adjacent side over the hypotenuse. And then we've got the TOA. Tan of theta is the ratio of the opposite side over the length of the adjacent side. Okay, so although this is fine, it's a great way to introduce trigonometric functions. It's very limiting when it comes to the angles that the trigonometric functions can be applied to. Obviously, a right triangle will never have a theta that exceeds 90, whereas trigonometric functions are often defined for all theta. The trigonometric functions are also, or more generally explained, by describing their relationship to the unit circle. If you recall from the previous video, the circle of radius 1 centered at the origin is formed of all points whose coordinates satisfy the equation x squared plus y squared equals 1. That's the unit circle. These points are all equidistant from the origin and are placed at an angle theta measured from the positive x-axis, as shown in the illustration. Angles, which we will be measuring in radians, increase when heading in a counterclockwise direction. Some points are easier to identify than others along this unit circle. We've got point 1, 0, 0, 1, which is located at an angle theta of pi over 2, minus 1, 0 at an angle of pi, and 0, minus 1 located at an angle of 3 pi over 2. Other points are harder to specifically identify, so the figure below shows a few of these points found within the first rotation. So we will not discuss how all of these different coordinates were obtained. That's not necessary at this point. Obviously, the same coordinate points are obtained for angles that occur full rotations later or previously. In other words, points on the unit circle at angle theta and at angle theta plus or minus 2 pi are